Welcome back to episode 5 of my Beginner C++ series. We are now going to take everything we learned so far and make a little program with some actual logic that does an actual thing. And what we're going to make is an adder. It's just going to be a program that runs in a loop as long as the user wants to continue and either adds, subtracts, multiplies, or divides two numbers. Now if you can think of how to do this on your own, I encourage you to pause it right here and attempt to build this adder yourself. Otherwise, if you don't want to give it a go on your own and want to just see how it's done, let's jump into it. So first of all, I'm going to delete all this stuff, and I'll put episode 5 here. An adder, or more like a calculator. So doing these little programs where you have to control flow are great practice for when you're a beginner. And if you go to school or boot camp, this is some of the first lab stuff they'll have you do, is things like this. Okay, I'm going to keep this as running variable, and I'm going to leave that true. The number of loops to run, we're going to get rid of that because we're not going to use that. But we do need a flag for whether the user wants to do an add, a multiply, or divide, or plus, minus, multiply, or divide. And we're going to do a while loop, and we're going to do this while is running. Now sometimes you'll see while is running equals true. That might be a little clearer, but it ends up just checking what this evaluates to. So since this is a Boolean, we can leave it just by itself, because it's by itself it evaluates to true, and when it's false it evaluates to false. So it's good enough just like this. But you'll see it both ways. It is a little clearer when you read it like this, or sometimes you'll say the while not false, which is essentially the exact same thing. But so just want to point that out because that is something you do see. So while it's running, we're going to keep taking calculations basically. So at the very end, we're going to want to check whether the user wants to continue or not. So let's go ahead and put that in. And we're going to just be using the console in and out for this, so we won't need any other headers other than the plain old IO stream. So we'll put at the very end, do another calculation, and we'll put in parentheses here yes slash a y slash n, representing that we want to take those. And then right here we'll take a cn, and we kind of need something to hold the value, so we'll just do a char called we'll just call it answer, and we'll set it equal to 0 to start out. That way it doesn't have a random value. And we're going to cn answer. Then we'll say if answer equals y. So if they end up pressing y and then enter, we'll just say continue, which basically breaks to the next loop. Otherwise, if they don't press y, we'll do an else. And this else will be, oh, there's that again, is running equals false. So this little chunk here is going to ask the user if they want to do another calculation, perhaps this variable in case we need it. We could also just do this up here so it doesn't always redeclare, but I'm going to do it here just to keep it encapsulated in the place it's used. And we're going to check if they pressed just the y character and continue, and if it's anything else. So the yes no is a little, I mean, we could make it a little more careful about what it takes in, and actually check for y, capital Y, etc. But we'll just put y to do another sometimes making these console programs clear takes some careful analysis, but that should take care of it there. And there we go. So now if we just run that, we will get, well, let me go ahead and g++ main.cpp. Runs. Do another calculation. Yes, yes, yes. As long as we're hitting Y, it's gonna keep going. As soon as we hit something else, it'll exit. So there we go. That's how we keep our while loop running in this particular instance. Now we want to have the logic here to do our actual little calculation thing. First thing we need to know is, do they want to do plus, minus, or divide? So we'll take in that. So first here, we will declare, we need some kind of variable to do an if-else on, or a switch on. You know, I haven't showed you switch yet, so I'm going to show you switch. Switches are very much like an if-else, but they're basically a big if-else that works off of only a single variable. And they're a little bit more efficient than an if-else. So if you don't have really complicated logic and you just want to do potentially multiple different things depending on what one variable is, a switch statement is going to be better. So we'll use a switch, and maybe we'll use some if-else's too. So we'll declare an integer for our flag, and we'll call this, we'll just call it choice for now. Pretty plain name. And we'll start it out with a 0. And we'll ask the user, and we'll give them a little feedback here too. Press 1 for add, 2 for subtract, and 3 for multiply, 4 for divide. And you can make this however you want. This is just kind of a way for me to get it done. As you see your cout, maybe it won't look good, and you can carefully make your syntax better and clearer if you need to. Then we'll just do a cn on this choice. So anytime you do this cn and bring in a variable, you're waiting for a user prompt on that variable. And then we'll do a switch on our choice. And this is the syntax of a switch. You start out with switch, the variable you want to switch on, a set of brackets to go into the scope, and then you start doing cases. And you do case 1, because we want to do different things for 1, 2, and 3. So we're going to have cases 1, 2, and 3. And at the end of every case, you do need a break, or it keeps going down. It doesn't short circuit like if else does. If you don't break, it'll keep checking it'll keep going. So I'm just going to initially build these cases. And then at the end you want a default for if it hits none of them. And we'll just say if they end up going to the default, we'll say not a valid choice. But on these other ones, we want to start doing our calculation. And in these cases, you can just start doing your code, or you can also enter a scope. If you're declaring variables in your case, you do need to enter a scope. But that's not absolutely necessary. We are going to enter a scope because we're going to, well, I guess we don't necessarily need to, but we do need to take in some numbers to add, subtract, multiply, or divide. So up here we're going to have, we'll use floats, and we'll do first number and second number, and we're going to start these out as zeros. So I'll do an equals 0 equals 0. Now we could also keep these within the scope of just this too, and that way every time the loop restarts they reset to 0. So actually this might be a little better, and I'm not doing them static because I do want them to redeclare just to reset their values. If I did them as static, they would stick as the number they were before, which might not necessarily be what we want, especially for choice. But in this case, it's not going to matter a whole lot either way. So in case 1, they chose add. So we'll do another prompt here that says enter first number to add. And then we'll cn first number. And then we'll do a cout to prompt enter second number to add. And we'll do a cn second number. And that'll prompt them for what we need. And I'm going to clean this up a little bit and just do add numbers. So that way it reiterates what they chose, and that way I can get rid of this, and I'm going to be reusing some of this code. And then so once those are prompted in, we'll spit out the result. So the result of first number, put a plus symbol to let them know what we're doing. The second number, and equals here, and then we'll add them together. And then we'll do a new line. So right within the cout here, it's going to do the calculation on the fly. Now we could declare another variable, do the calculation ahead of time, and then spit out the new one, but this works fine too. So there we go. So if we go ahead and run this, we can test that it actually does at least the add portion. And what doesn't it like here? Oh, I forgot to put more little alligators things. More less than symbols. Okay, and now we'll run it. And we do get our prompt way down here in the corner here. Press 1 for add, 2 for subtract, 3 for multiply, 4 for divide. So we'll go ahead and press our 1 and enter, and it tells us add numbers, enter first number. How about 5.5 and 6.2? And there it tells us our result. Maybe I'll make it a little more explicit and even say result here. And there we go. We have a basic adder that we can run in a loop. If we want to do another, we press yes, and we do it again. If I hit 4, it's going to do nothing because it's going to go to this case that we haven't built yet. But if you didn't go ahead at the very beginning and do this all on your own, now would be a great chance to pause the video and attempt to build these other 3 cases on your own now that you see how the adder's done. And that would be a great little getting started experiment for you. Okay, there we go. So let's build the next ones. Here's the answer. I'm going to go ahead and just do some copy paste to make this quick. So this is no longer add, it is subtract. And we're going to change this so that tells the user it's a minus. And of course this over here needs to be a minus. So there we go. So that would take care of the subtract. And now we want to do the multiply. And I'll just update these. To represent what we're doing. And now we want to do the divide last. Now, one thing that's pretty cool is that I used to like to do when I was a pretty new coder is I used to like to build these for different calculations I had for whatever project I was doing. And there's more tricks you can do than just always prompt, like you can pull in from a file, which I might start showing starting next episode so we can get even more advanced. I can show you how to work with other files and not have to manually type things in with cn all the time. Okay, we'll do divide numbers. Divide. Now divide is a little trickier because dividing by 0 results in infinite and will often crash your program. So let's go ahead and run this. I'm going to do a clear and compile And now we will run it. And we're going to do our divide, because I think the rest are pretty well built and should work just fine. But I want to show you what happens when you divide by 0. Enter first number. We'll do 5.5. Second number. What if we put 0 here? Well, this particular compiler knows how to handle it and says infinity. But some older compilers do not know how to handle this, and they won't give you a result. They will just crash. So it would be a really good idea to make sure this second number was never 0. So what we could do here is we could do a little control flow and say while second number is not equal, or while it equals 0. And we'll do this sort of thing. And you know what? Let's actually use a do while, because we definitely want to do it once no matter what, so we can get the updated number. But if it's 0, we want to loop and do it again. And we'll put a little notification here. If it is 0, we also want to say can't divide by 0, try again with second number. And I'll put a little new line there. And I guess it might be better to have this in here too, so every time it loops, it puts the prompt in front of it. So there we go. That'll make sure we don't get a 0 in that slot. So let's go ahead and run that. We'll exit our program there, recompile. We'll test our divide, enter first number, second number of 0. Let's make sure, yep, it says can't divide by 0. Try again. We'll keep. So it's just not going to allow it. And there we go. Now, something I will warn you of as a final thing as I end this video is this is a float, right? And a floating point number, this compiler handles this particular thing fine, like it does in Infinity. I guess it's a little more advanced or updated. But a lot of them, a lot of floats, even if you set them to exactly 0 and then compare them to 0, it will end up being false. And the reason that is because they end up being a value that looks like, let's see, something like this. And that's not exactly 0. So on some compilers, this will never work correctly with a float. So you'd want it to be an integer. So a little bit of a more careful way to handle this would be to cast this as an integer as you check it. But that might not actually that's going to cause problems too. I guess I'll just say you might have to think of a better solution, such as putting a limit on it, like something like if it's less than that and ends up being greater than, and just put it within a boundary like this and a negative. So this might be a better way of checking for if a float is 0. If it's less than that tiniest one it could be and greater than the negative of that, and that way it's like a clamp to 0 basically. So that should essentially work the same. And of course we would update our one down here. But that's just something to know about floats. It's something I've been stuck on before, and for the life of me couldn't see the bug because I was like, it's a direct comparison, it can't be wrong, and it ended up being the source of my problem. So there you know, there you go. So we'll give that a test. If we enter 0 with our new, yep, still detects correctly. Okay, and we can keep our loop going. We're pressing Y and just keep doing calculations. This might be something like this might be good for doing something like an interest calculator for different interest rates, where you could punch in the interest rate, the yearly amount, run your calculation, things like that. Well, I hope you enjoyed this episode. I hope you learned a lot. It's been really fun making these so far, and teaching the world a little about coding. So I will see you in the next episode. I'm going to scroll through this one last time in case someone wants to see it all. Or I guess I can make it a little tinier and fit it all on the screen at once. There we go. That's it. Alright, see you in the next episode. Have a good day. Keep on coding.